So when you're using the ideal gas equation, sometimes you will be asked to answer questions involving a gas that is at what's called standard temperature and pressure. And many times that standard temperature and pressure will be abbreviated with just the letters STP. So it might say something like a gas at STP. And when they do that, they're actually trying to help you. It sounds like it might be a little bit more confusing, but it's actually not. When they say a gas is at STP, they're telling you the temperature and the pressure every time. So STP is defined as a temperature of 273 Kelvin, which is 0 degrees Celsius, and a pressure of 1 atmosphere. So anytime a gas is at STP, you immediately know the temperature is 273 Kelvin and the pressure is 1 atmosphere. So, in example number 4 here, it says 4.25 grams of helium gas at STP has what volume? So again, always start with PV equals nRT, and they're asking us for the volume, so we have to solve for V. So that means we're going to divide both sides by P. So the volume of the gas is equal to the moles times R times T over P. Okay, now they give us the mass of helium, so like the problems in the previous video, when they give you the mass of something, you have to convert those grams to moles. So we're just going to show that right in our process. So 4.25 divided by, and then I look at a periodic table, the molar mass of helium is 4, and by taking the mass dividing by the molar mass, that's going to give me the moles. And then R is 0.082 liters atmospheres. Do the whole thing, Kelvin mole. And then the temperature, no, it doesn't give us a temperature, except it does. It's an STP standard temperature, 273 Kelvin, and the pressure is 1 atmosphere. Okay, so now we take our 4.25, we divide by 4. That gets us to moles, and again, if we've done this correctly, everything should cancel except for the units for volume. So moles cancel, kelvins cancel, atmospheres and atmospheres cancel. What do we have left? Liters, which is a unit for volume. So 4.25 divided by 4 times 0.082 times 273 divided by 1 equals 23.8. And again, what's my unit for volume? Liters. Okay? And that's really all there is to STP. There's actually even an easier way to use STP, is that if you think about, it doesn't matter what the gas is. In this case, it didn't matter that it was helium. It could have been CO2, it could have been SF6, it could have been argon. It could be water in the gas form. It could be any number of any gases. Okay, but if you notice here, if I take this part away, the moles part, if I put 1 mole here, right, and it doesn't matter what gas it is. It could be a mole of helium, a mole of carbon dioxide, a mole of any gas. You'll notice that none of the other numbers change. So if I have 1 mole of any gas, so 1 mole at STP, it's always going to have the same volume. Okay, well, what is the volume? Well, put the numbers in. 1.00 times 0.082 times 273 divided by 1 equals 22.4 liters. Which means that if you're given the moles of a gas, let's say you have 2 moles of a gas and you're at STP. What's the volume? Well, you just double 22.4, 44.8. What if you have half of a mole of a gas, any gas at STP? Well, what's half of 22.4? 11.2. So one of the nice things about STP, anytime I see those letters STP, this is the number that pops into my head, 22.4. Because if I can, I'd rather not do all of this work. I'd rather just go, oh, well, how many moles do I have? Oh, I have 3 moles. Oh, well, 3 times 22.4 is 67.2 liters. Okay, so whenever you see STP, always try to think of that 22.4, which will help you in terms of in terms of doing less work, but still getting the correct answer. So, and that's what I talked about here. Again, 1 mole of any gas equals 22.4 liters, again, at STP. You have to be at STP. If you're not, then that relationship doesn't work. Okay, so doing, solve example 4 above using this new relationship between moles and volume at STP. So we had 4.25 grams of helium. So another way we could have done this is we could have gone 4.25 grams, and then just showing more of my work here, there's 4 grams in 1 mole of helium, which is equal to 4.25 divided by 4 equals 1.06. And then that's the moles. And then I could have just multiplied that by 22.4. And times 22.4. Big surprise. What answer do we get? What answer did we get up here? 23.8. What answer do we get down here? 23.8 liters. Okay, so STP, it's just a way that you can do problems a little bit easier if you want to. But notice the key there. Notice that I still did this whole problem correctly using the moles, the 4.25 divided by 4 moles times R times T over the pressure, and I still got 23.8. So there's never a requirement, but that 22.4 is just kind of a shortcut when you're dealing with gas laws, when you're at STP. Okay, so question example number 6 here says, how many moles of xenon gas are present in a 9.32 liter container at STP? So if we have 9.32 liters, remember 1 mole equals 22.4 liters. So just like in the past, just like when we did conversions in the past, when you know two things are equal to each other, we can simply just go 9.32 liters and then go 22.4 liters equals 1 mole. And again, that works because we're at STP. So 9.32 divided by 22.4 equals 0.416 moles. Now, remember, you don't have to do it that way. You can go, oh, well, I have the volume, I have the temperature, and I have the pressure. I can solve for moles. Remember, the answer was 0.416. I can still just use PV equals nRT. PV equals nRT. They're asking me for moles, so that's N. So N equals divide by RT, right? RT. PV over RT. So the pressure is the standard pressure. So 1.00 atm times the volume. There's our volume, 9.32 liters, over R, 0.082 liters atmospheres. Remember, put that Kelvin mole on the top. And then the temperature is, again, the standard temperature, which is 273 Kelvin. And again, if we've done this correctly, then we know that atmospheres have to cancel, liters have to cancel, Kelvin are going to cancel, and what are we left with? Of course, moles. So then I take 1.00, I multiply by 9.32, I divide by 0.082, and I divide by 273. And big surprise, what do I get? 0.416 moles. Okay, so STP is just, there's just, again, they're just trying to help you. They're just telling you, look, without actually specifically saying this is the temperature, this is the pressure, anytime you see STP, you know that the temperature is 273 and the pressure is 1 atmosphere. You also know that when you're at STP, 1 mole of any gas equals 22.4 liters. And you can use that conversion to easily convert between volume and moles, or vice versa.